Exercise 14b, question 8, okay? And what it's looking for us to do here is the diagram shows a rectangular laminate of mass M, length 6L and width 3L. A point mass of M is attached to K and the midpoint of one side, okay? So the system is free to rotate about a horizontal axis through P. So it's actually parallel to the board. So number 8. Okay, or sorry, number 9. A thin rod of XY of length 2L and mass 3M has a point M attached to the end point Y. The compound body is free to rotate a horizontal axis through X. Okay, a horizontal axis through X, okay? Perpendicular to XY. So it's perpendicular. Once again, it's going into the page, okay? And then perpendicular.
This is
keyword perpendicular to XY, okay? And it's just a thin rod, okay? And it has a point, it has a mass M. So look, this is actually technically this is two rods. It's actually showing the same rod twice. Do you see the rotation? So basically what's happening is, if I was to draw just a quick one here like this, okay, what's actually happening is this. It's going around like this. Okay, so that's what's actually happening. So don't let the diagram fool you. Okay? It's actually rotating around like that. Okay? Now, so that's cleared up. Okay? Let's figure out the rod is being held by its end point. Okay? So the equation for a rod held at its end point is, and this is for the rod is in black, okay? So it's a moment of inertia about an axis perpendicular to the plane, okay? Is going to be 4/3 ml squared. But there's a problem with that. The mass is not M, it's 3M. And the length of the rod remains as L. And this is going to get us 4 ml squared. Huh? Oh yes, but the formula is set for a length of 2L and mass M. So the only thing that changes is the mass. Okay? If you look at the tables, it says mass length 2L. Okay? Now we're going to go for the point mass. Okay? Which we'll do in purple here, right? So point mass.
So that'll be L cubed. You've got 3.
Oh, sorry, not meant to have an L there. It's just 3ml squared. Okay? Point mass. Okay? Point mass around X is M times the distance away, md squared. So it's M times 2L squared, and that will get us 4 ml squared. Okay. Now the mass, the inertia of the system, or I system, will be equal to this one plus this one, which gives us 8 ml squared. Okay. So okay, so that's all our information there in the top right now, okay? Now, next thing we got to do is find out the system is released from rest, okay? So we're going to do what we've been doing the last while now. We're just going to write down all the potential energies, okay? Potential energy of rod plus potential energy of mass plus rotational energy of system will equal the new potential energy of the rod plus the new potential energy of the mass plus the rotational energy of the system. Just realised I'm going to run out of space, so let's sort that out. Plus a half I omega squared system, okay? Now, what we gotta do is we gotta choose our point, our standard position point. Our standard position point is gonna be at the bottom here. Now the reason why we choose this standard position is when the point mass rotates fully around, the point mass is going to be located on the bottom. The point mass will have no potential energy but at the end of the experiment. So the end is to the right and the start is to the left. Start and end, okay? So let's figure out. The center of gravity of a rod is dead center. So it's going to be 2L plus L, which is 3L above the ground. mg 3L for the rod. The mass is located at the top, so it's going to be mg 4L. Okay. The system has no rotational energy at the start. Now at the end, the rod, its center of gravity is located L above the ground. Okay. Yeah, L. Now, I've made one mistake here. Can we tell you what the mistake is? The mass of the rod is not M, it's 3M. Okay? So just make sure that when you're doing this, you assess the mass of each individual piece. Okay? And don't make the easy mistake. So this is going to be 3mgl, because the center of gravity of a rod is halfway up its length. That's why it's length L above the ground. So 3mgl plus 0. Now, plus a half IW squared. 7 mgl on the left, or sorry, not 7 mgl. 16 mgl on the left, 3 mgl on the right. Oh wait. Was it moving at the start, lads?
Yeah, it started.
Sorry, it gets set off with an angular speed. So unlike previous questions, okay, it gets set off with an angular speed. So what we have to do is we just have to do a quick adjustment here, okay, and the quick adjustment will be this. Okay, show you the quick adjustment now. Usually it's not moving at the start, but this time it is. So it's going to be a half I W squared. W is G over L. So it's going to be G over L. Now what we need to do next is we need to change this I into, what's it, 8ml squared, yeah? So a half 8ml squared. What's a half 8ml squared? 4ml squared G over L. The L will cancel. So it's just going to count as a 4mgl. This one here is 9mgl. This one here is another 4mgl. Bring the 3mgl back over to your side. And this all equals a half I omega squared. Now what happens here is 13, 17, it's 14 mgl. Ends up to be a half I W squared. Cross multiply 28 mgl. Ends up to be I W squared. Change I into 8 ml squared. W squared equals 28 mgl. The L's will cancel. One of the L's will cancel. One of the M's will cancel. Huh? Yeah. 8 into 28. 7 over 4. Or 28 divided by 8 is it 7 over 2 or 7 over 4? 7 over 2, sorry. 7 over 2 G all over 2L. So I'm setting this L down with it. Okay, equals omega squared. Omega therefore is equal to the square root of 7G over 2L. Does this question ask for the speed, or does it ask specifically for the angular velocity? Angular velocity. That's how it changes from the. It doesn't actually ask for the actual speed. It asks for the angular speed. Okay. So that's it done there. Well,